welcome back everyone. Today we'll continue our data structure series with N-ary tree program. Before moving to the coding part, let's study the definition of the tree. Tree is recursive collection of nodes where each node contains data and a list of reference to other nodes. Here you can see the diagram of a tree where root will be the first node and these are the branches, these are the childs of the root node, and the leaves are the nodes which are child of the branch nodes. Root will have its value as well as the list of references of these branch nodes, and branch nodes have their values and references of their leaf nodes, their child nodes. Today we will be doing an array tree. An array tree is a tree with each node having n number of childs, where n can be any number. So now let's move on to the coding part. Coding of an array tree will be quite similar to that of doubly linked list. So now we first define the class node and init function inside it with data as an input to the function, and it will carry three variables. First will be data, whose value will be data, and second will be child as next in the linked list, and child will be an empty list here, and the last one will be the root, which will point the root of the node, or you can say the source of the node. It will be none initially. Now we define the class to put the functions of the tree, and we will define another init function here which will carry the root, and it will initially be none. And now we need to define the insert function. In insert function we will take an input from the user, the input, the data of the node, and we will put this new data into a new node which will be the object of the node class, and it will take this data as the data of the node. Now we will check if root is none, which will be if self.root equals to none. If that is so, then we will put the new node into the root. This means that this is the first node of the tree, else means we already have the node, so we need to find on which node we are going to put this new node. So we will take input from the user, the value of the node where he wants to add another child node, and now we will check if self.root.data equals to nodeval. That means the node where user wants to insert the data is the root node, so we will add a new child to the root node. So new node's root will become self.root, and one of the roots child will be added, and that will be the new node. So we will append new node to root's child. Now if that node is not root, then we need to find that node. So in else part we will continue with a function. Let's call it as findinsert, and we will pass two variables into it. One will point the current node, first node will be root node, so we will pass root into it, node variable, actually three variables, and a new node. Now we define the findinsert function. We need to define all the variables as mentioned while calling. That will be current node val, and new nodes we should write new node as nw here. So now we start a loop to check where our node exists. if I in current.child. Current will start from root because we have given root in the else part in previous function. Now we will check if i.data equals to nodeval. Then we will put this new node as the child of that node. So for new node's root, we will put I as its root, and i's child, we will append this new node into i.child. Now in the else part, if we do not find the node, we need to continue to the next node. So current will become I, and we will pass this current again into the same function findinsert, and we will pass current comma nodeval comma nw, which is the new node here. Here we have done the insert. Now we want to display, so we will define a function display function here. We will check if self.root equals to none. That means we don't have any node yet, so we will print no nodes are available. In the tree. Now we will continue with the else part, where we have nodes in the tree. We will print root is the first node of our tree, which will be printed. Self.root.data, it will print the value of the root node. And now we will call another function. Let's call it as finddisp, and we will feed it value self.root as its only value, and we will define the function finddisp, and we will set the value current. And for the definition of finddisp function, we will first check if current have any child or not. For that we need to check if length of current.child is not 0. So we will put here length function, length of current.child is not equals to 0. Now we will run a loop. If that is not 0, then for I in current.child. Inside the loop we will print i.data. This will print the data of the child node, first child node. Then it will repeat with the loop. Now we will check inside the loop if the child node have any child. So we will check if length of i.child is not equal to 0, and if so, that length of child is not equal to 0, then current will become I, and we will recall the function finddisp, and we will feed current here as its input or the variable. And now in else part we will return, because we don't want to do anything if there is no child node. Now if we want to remove the nodes, we need to define a function. Let's call it as remove node. In this function we will take an input from the user, that will be the value of the node we want to delete. So we will put it as val, and input we will print in a statement, enter the node value to remove. And now we will check where this value exists in our tree. Here we forgot to do one thing. If there is a child of I, then we will print child of, this will just create another statement so we can differentiate which is child of whose. Now continuing our remove node function, if self.root.data equals to val, that means our root is the node we want to delete. We will first check if there is no child of the root node. Self.root.child equals to 0. Then we will, if that is so, then we will put self.root equals to none, if there are childs of root node, then we cannot delete the root node, so we will print can delete the root node now. The root node now. And now else of upper if root is not that node, then we need to again call another function. Let's call it as finddel or find delete, something like that. We will pass root as its first node. Now we will define the function. It will take one parameter. Let's call it as curr, current. Now for I in curr.child, same as that we checked in insert function, we need to check same as we did for the root. So we'll just copy paste it and just change few things, like self.root will become i i.data, and we need to take another value as parameter. That will be the value of the node to delete. We will take it as val2. Now we need to change this again. It will be i.child, and this self.root will also change. Root equals to I, that means the i.root, that we want to take the root of the child we want to delete and save it into rtt variable, and we will run a counter variable that will be 0 initially. Now we will run another loop for j in root.child. If j.data equals to val, that means the value of child which matches the value to be deleted. Then we will break from the loop. Else, if that is not so, then we will increase the value of counter variable, that will be count plus equals to 1. Now once we got the counter, we can pop that data from the list. So we will just pop that value and we will break from the loop. In else part, if there are some child of that node, then we cannot delete. We'll print the same story. And now in else of upper else, we will do current equals to I, and we will pass this current into our function finddel, and current comma val. Now we need to define our main here, and we will need to create another object of N-ary. It will take no parameters. We can copy this from here in our circular linked list. I will just copy it and make some changes as requirement of our program. We will only give 4 options here: 1 to insert, 2 to delete, 3 to display, and 4 to exit. Now we need to change our if else statement to here no. Okay, we will remove this part, and this remove from will become display, and this insert at will become remove node. Now let's run the program and check. 1 into data 12, 1 into data 35 at node 12. Let's check. Oh, we did some error. That's the name of the function, we wrote it wrong. Now it's corrected. Now see, now you can see the function is running. I hope you have liked the video. So if you got something to learn from this video, please hit the like button. If you have any doubt, please put it down in the comment section, and thanks for watching.